So let's start with the easy one first. All right, so this is 4.5. We're going to deal primarily with logarithmic equations. Okay, so if I have the ln of x equals 8, how would you solve that one? Daniel, it must be your turn.
Divide by ln.
You can't divide by ln. But we got to get rid of it somehow. It's just not through division. And you know, this is how you get rid of that ln. Michael?
We're putting in an exponential form.
Yeah. So technically, you could take the inverse log, and then it would go away, right? But it's kind of a strange way to write it. So what's the base when you have here? E. So rather than doing that, you could say, well, I'm going to make this the exponent, right? I'm going to put a big fat E there. Okay? So x would equal e to the 8th, right? One step. Nice. That's easy. Okay? Now, should we check it and make sure it works? The ln of e to the 8th, does that equal 8? Sure does. Okay? All right, how about another one? How about if I did log base 2 of 25 minus x equals 3? So, Daniel, since Michael bailed you out, what do you think?
Let's see. Would you? Well, you can. I'm not sure exactly.
Well, what do we got to get rid of? We can't divide.
Well, you've got to get rid of the log.
Okay.
25.
So how do we get rid of the log without dividing?
Changing the form.
Okay. And what's the base?
2.
2. So what do I do?
Two is.
We can take the inverse log of this, which is the same thing as putting a big base of 2, right? So let's convert that out, and we're going to get 25 minus x equals
Is 2.
2 to the third power is
8.
8. How do I solve?
Just subtract 25 and divide by -1.
So negative x equals negative 17. Divided by -1, I get x equals 17. Now, let me just mention one thing here. We haven't been paying too much attention to checking our answers, but I will tell you, when you deal with logarithmic equations, sometimes you get answers that actually don't work. And so it is a good idea to check these. So if I had the log base 2 of 25 minus 17, does that equal 3? So 25 minus 17 is 8, and log base 2 of 8 is 3, so that one does work. Okay? So those do tend to cause some problems. Okay, how about this one? What if I want you to solve 4 plus 3 log of 2x equals 16. So, Lauren, let's do your turn. Subtract the what? The 4? So 3 log of 2x equals 12. And then what? Divide by 3. So that'll go away. Log of 2x equals 4. Okay, what do you not like about this problem? Okay, because the log's in the way, right? So how do I get rid of the log? What's the base? 10, right? So what do I do with the 10? We don't multiply. Technically, we're doing the inverse log, right? But another way to think of that would be to just put a big 10 as your base right there, right? So that'll wipe that out, and I get 2x equals a 1 with 4 zeros, right? 10 to the 4th is 10,000, okay? And then, divide by 2, x equals 5,000. Should we check our answer? Okay, this is 4 plus 3 times the log of 2 times 5,000. Does that equal 16? So 2 times 5,000 is 10,000. Log base 10 of 10,000 is 4 times 3, 12 plus 4, 16. Okay? So that works. Okay? All right, how about, let's do this one. Log of x squared plus 1 equals the log of x minus 2 plus the log of x plus 3. Okay? Debbie, you look like you wanted to do this one.
Would you?
Oh, you didn't tell me we're off screen.
I want to subtract the log of x plus 3, but I don't want to have that.
You could subtract the log of x minus 3. Wouldn't be that helpful.
Would you put, since the log of base 10, would you?
It would be nice if we could do the inverse log here.
Yeah.
But the problem is I get that plus in the way. Is there any way I can combine those?
Would this be log x squared plus 1?
Well, you'd multiply both of those together. So that would be x minus 2 and x plus 3. You can combine those with those rules that you didn't forget, right? Remember that? Okay. And so now, equals the log of x squared plus 1. Now that I have a single log on each side, now you can do what you wanted to do. Okay? What's the base?
10.
Base 10, so do the anti-log or the inverse log, and then it's just like putting a big 10 there, right?
Yeah.
So that's going to wipe that out, wipe that out. I'm left with x squared plus 1, and then can you FOIL that out for me?
Would be x squared plus 3x minus 2x. That's 6.
Minus 6, okay? The x squareds cancel each other, right? And so now I need to combine all my x's. So 3x minus 2x is 1x. And I can add 6. So x equals 7. Okay? Now, once again, this is a good one to check, because sometimes these mess up. Okay, so we started here. The log of 7 squared plus 1, does that equal the log of 7 minus 2 plus the log of 7 plus 3? Okay, 7 squared is 29 plus 1. The log of 50. Does that equal the log 7 minus 2? 5. Plus the log of 7 plus 3? 10. Can I combine those? And that becomes the log of 50. The log of 50 definitely equals log of 50. So that is the correct answer. Okay? All right, let's do another one. How about if I do log of x plus 2 plus the log of x minus 1 equals 1. I think Nicole wanted to do this one. I was right, wasn't I? Okay, what do you think? We combine the logs into a single log, and that would be the log of equals 1, right? Now that I've got a single log, yeah, the inverse log, which is just like putting a big 10 there. Okay, that becomes you're so quiet I can't hear. X squared plus 2x. Is that what you said? I hope that's what you said, because it's right. So x squared plus 2x minus x minus 2 equals 10 to the first power, which is 10. Okay, how would I solve that? Combine the x's, so this is x squared plus x minus 2 equals 10. I don't want to add the 2. I want to subtract the 10. You notice that that equals 0, right? Okay. So 0 equals x squared plus x minus 12. Should have picked on Cameron sooner, dang it. Okay. And then that factors into x times x, right? Factors of 12. 3 and 4. Which one's plus, which one's minus? It's going to be plus 4 and minus 3. Okay? So therefore, x equals 3 or x equals minus 4. Okay? Now, anytime I see a negative, it always makes me a little bit nervous, right? So maybe we want to check that one. You got a question? Yeah. Oh, you're good. So let's plug in the -4 and make sure it's okay. So we started here, log of -4 plus 2. Is that a problem? Can't take a log of a negative number, right? So I get to throw out that answer. It doesn't work. Okay? Let's check the 3. Log of 3 plus 2 plus log of 3 minus 1. Does that equal 1? Okay? 3 plus 2 is 5. Log of 5 plus 3 minus 1, 2. Log of 2. Does that equal 1? I can combine those. That becomes log of 10. Log of 10, does that equal 1? Sure does. So that one is the correct answer. So I have one good one and one bad one. Okay? So once again, very important to check. Okay? Well, I don't think I gave you any of those. I should, though. All right, let's do one more just for fun. See how good you guys are. Let's say that $5,000 is invested continuously at 5% per year. Find the time required to double your money. Okay. So Eunice, it must be your turn. Any useful formulas you think might help?
Let's see, so we have, oh, the A equals,
A.
A equals B times,
A equals part. It's continuously, right? Remember that one? A equals part. Okay? All right, so that's a very useful formula. You'll never forget that because we'll probably use it a lot. Okay? And then what?
So we're trying to find A, right?
Well, we want to double your money, right? So what's your principal? 5,000. And if you double your money, how much are you going to have? 10,000, right? And E is still E. What's your rate? 0.05. And T is, what'd you say? T is your time. So we'll leave that with that. So you get to solve for T. How do we do that? We can, but that 5,000 is in the way. Got to get out of the way first. Divided by 5,000. So 10,000 divided by 5,000 is 2 equals E to the 0.05 times T. Now you can take your ln. The ln of 2 equals 0.05 T divided by 0.05. So T equals the ln of 2 divided by 0.05. And as everybody knows, that answer is 13.86 years. Okay, about 14 years. Okay? Piece of cake. Okay, so your quiz on Monday is going to be on the rest of 4.5. And we'll see you all on Monday. Do you think this will be fixed by then? No, I don't think so. Okay, see you all on Monday.